Hello everyone, this is Siddharthan. This is our fourth project video, and in this video we are going to see how we can build a house price prediction system using machine learning. Okay, so this is a complete hands-on video, and we will be doing all our programming in Python. And for this prediction system, we will be using a XGBoost regression algorithm. Okay, so this house price prediction is a regression problem. Okay, so first of all, let's try to understand more about this problem statement. Then we will discuss what is the approach we will be taking to solve this problem, and then we will get into the coding part. Okay. So first of all, let's understand what is meant by regression. Okay. So generally, machine learning is classified into two types. They are supervised learning and unsupervised learning. In supervised learning, we will train our machine learning model with lots of data. Okay. So these data are labeled data. So we will be provided with labels. So in this house price prediction case, the label is nothing but the price of the houses. So because the price is what we are trying to predict, right? So that will be our label. Okay. So in the case of unsupervised learning, so we will be training our machine learning model without this label. Okay, so this supervised learning is further classified into classification and regression. So you can see what is meant by classification and regression in this slide. So basically, classification is about predicting a class or discrete value. Okay, so the previous video, the project video we have seen is about predicting whether a person has diabetes or not. So this is a classification problem because we are just predicting the case is either this or that. But in the case of regression, we want to predict a continuous value, a number or a quantity. Okay, as in the case of this project where we want to predict the house price. Okay, so this is not some kind of classification, but we want an actual number. Okay, so these problems are nothing but regression problems. So this house price prediction is a regression problem. Okay, so let's try to understand more about our data set. Then we will see what is the workflow we will be following. Okay, so I have given a sample data for our data set, and above statement is the description of this data file. Of course, so this is basically the Boston house price data set. So we know that Boston is a famous city in the United States. So this data set basically contains 506 entries and 14 features. Okay, so you can see the columns in this sample data set. So the last column represents the price. So the price values are in the thousands of dollars. Okay, so for example, you can see the last value in the first row, which represents 24, right below the price. So it represents $24,000. Okay, so the unit is $1,000. So likewise, we have lots of columns here, right? So the first column represents CRIM. So CRIM basically means the per capita crime rate by town, and ZN represents the proportion of residential land zone for over 25,000 square feet. And here we have this NOx column, right? So it represents the amount of nitrogen oxide concentration. So like this, there are various columns and features. Okay, so the tax represents the amount of tax and all those things. So you can understand more about this data set in either use a machine learning repository or in Kaggle. Okay, so you just can search as Kaggle house price data set. So you will find the description of this data set. Okay, so there you can find what all those columns means. So basically we have 14 columns in this. If we give the first 13 column, the value of first 13 column, our machine learning model should predict the price of the house. So this is the goal of this project. Okay, so now let's see how we can solve this problem. So this is the workflow. So first, of course, we need this Boston house price data. Okay, so what we need to do is we cannot feed this data directly to our machine learning model. Okay, so we need to do a lot of processing before we can do that. So we need to do the data pre-processing steps. Okay, so in this step, we will feed our data to a data frame, and in the data frame, we will do some processing. Okay, so by that processing, our data will be suitable and compatible to feed to the machine learning model. Okay, so once we process the data, we have to do some basic analysis on the data. So we need to find the correlation between various features. So we have seen that the data set has 13 features, right? 13 features and one price column. So we can try to see which 13 of these features are interrelated. Okay, so that we will be doing in the data analysis step. So once we have some basic data analysis done, we can split the data set into training data and testing data. Okay, so this is called as train test split. So we will feed this training data to our XGBoost regressor algorithm. Okay, so and we will evaluate our model with the help of testing data. Okay, so these are two data splitted from our original data set, because the training has to be done with one type of data and the testing has to be done with new data. Okay, so that's why we are splitting it. So and XGBoost regressor is a decision tree kind of classification algorithm. Okay, so it is very much useful for regression cases. So this XGBoost regressor. Okay, so there is also XGBoost classifier and also XGBoost regressor, as our problem statement is a regression where we need to predict a continuous value or a numerical value, which is the price. We used a regressor model. Okay, so this is the workflow we will be following. Okay, so now let's get into the coding part of this use case. So I'll close this slide. So in Google, just search for Google Colab. Okay, so we will be doing all the programming in Google Collaboratory. Okay, so Google Collaboratory is a Python environment where we can do Python programming. So I have made a complete video on Colab basics about various features of Colab. So the index of this video is 2.1, so you can search in my channel. So here you need to give new notebook. Okay, so I'll give a card for that video if you are new to Google Colab. Okay, so I can rename the file here. I'll rename this to project 4, which is house price prediction. Okay, so you need to connect the system here. So this basically is a cloud-based environment where you can run Python programs. Okay, so we will get connected to a backend Google servers, and all the programming we are doing here will be run on those Google servers. So it is completely free, and it is very much useful for machine learning and data science applications. So you can check the amount of RAM and disk space you are allocated to. So we have a RAM of about 12 GB and disk space of 100 GB, which is really good. So this is where we will be doing all the Python programs. So this is called a cell. Okay. So now we can start the programming for our house price prediction. So you can write the code in this code cell, or you can create a text cell where you can make some comments about your code. So what basically you are doing in that particular cell. Okay. So first of all, we need to import the dependencies. The dependencies are nothing but the libraries and functions we will be needing for this use case. Okay. So I'll make the text here as importing the dependencies. Okay, so importing the dependencies, you can press shift plus enter to run that particular cell and go to the next cell. Okay, so first of all, let's import numpy. So import numpy as np. Okay, so numpy is very much useful for making arrays. Okay, so those arrays are called as numpy arrays. And then we need to import pandas as pd. So pandas is useful for making the data frame. Okay, so pandas as pd, and import matplotlib.pyplot as plt. So matplotlib is very much useful for making plots and graphs. And we need another library for plotting, which is cbon. So import cbon as sns. Okay, and now we need to import sklearn.dataset. So import. So sklearn is a very important machine learning library from which we will get few datasets and a lot of machine learning algorithms and other functions. Okay, so sklearn dot datasets. Through this datasets module, we can get that Boston house price data. Okay, so okay, so we need to, okay, so import sklearn dot datasets. Okay, now we need to import the function train test split. So this function is used to split our original data into training data and text data. Okay, so import, okay, so not import, it has to be given as from sklearn dot model selection import train test split. Okay, and then we need to import our XGBoost regressor algorithm. So from XGBoost import XGB regressor. So you need to note all those capital letters and small letters. So import XGBoost, from XGBoost import XGB regressor. Okay, and we need to import the metrics module from sklearn. This is useful for evaluating our model. Okay, so from sklearn import metrics. So these are the dependencies we will be needing. So run this cell. As I have told you earlier, you can press shift plus enter to run this cell, or you can press this play button or run button. Okay, so I'm pressing shift plus enter. So this cell has run. So we have imported all the dependencies. Now we need to import the Boston house price data. So I'll create another text and I'll mention here that I am importing the Boston house price data. So house price data set. Okay, so we will be importing our dataset from sklearns.datasets. Okay, so I'll create a variable for storing this data. Let's create the variable as house price dataset. So house price dataset is equal to sklearn.datasets dot. So you can see this load Boston data. Okay, so that is the dataset we need. So load Boston. And you need to mention the parenthesis here. So it means we are taking one instance of this dataset. So you can press shift plus enter again. So this will load the dataset into this house price dataset variable. Okay, so we can now print and see the data. Print house price dataset. So this is our data. So you can see a lot of values here. So these values are stored in the array called as data, and there are another set of values from here. Okay, right, so these are stored in the array called as target. Okay, so this target represents the price of the houses. Okay, so this target means the label of this data set, and this data represents all the other 13 features. So we have seen that crime label, tax and age label and so on, right? So this data has the values for all those 13 features, and target represents the 14th column, which is the price of the houses. Okay, now we don't want this data as such. Okay, so we want this data to be more structured. So for that purpose we will be using the pandas data frame. So that is the reason why we imported the pandas library. Okay, so now we need to load all this data into pandas data frame. Okay, so I'll make a comment here. So if you proceed your script with hash, the Python interpreter, so interprets that we are making some comment about the code. Okay, so it is a good practice to include comments in your code to understand what you are basically doing. Okay, so loading the data set to a pandas data frame. So I'll create the name for this data frame as house price data frame. House price data frame, the function for this is pd dot data frame. So I have imported pandas shortly as pd, that's why I'm using pd here. So pd dot data frame. Okay, one second. Okay. So data frame, here we need to mention the data which we need to load it. Okay, so we'll be loading this data array to our data frame. Okay, so for that we need to mention this house price dataset dot data. Okay, so pd dot data frame, in the parenthesis I am including house price dataset dot data. Okay, now we need to mention another parameters as columns. Okay, so this columns is nothing but the name of all the features. Okay, so these are the feature names. So you can see in the last line here, so we have these arrays. So we need to include all those feature names in our first row of the data frame. Okay, first of all let me show you what happens if I run without this column parameter. Okay, so our data frame is created. Now let's print the first 5 rows of our data frame. So print first 5 rows of our data frame. Okay, so for that you can use the function yet. So you need to mention this data frame name here. So house price data frame dot yet. This yet function will print the first 5 rows in this data frame. Okay, so there is some indentation here. Okay, as you can see here, we have we have not included the columns parameter. So what happens is, so we don't have the column names, so it is, we just have the serial numbers as 0 1 2 3. So we don't want that. We want this feature name to be in the first row, right? So for that purpose we need to mention the column variables. So mention columns is equal to, so we want this feature names arrays to be in the first columns, so mention that here. So house price data, house price data set, because this is in the variable called as house price dataset, so hence we are mentioning it here. So house price dataset dot feature names, so this will give the column names for it. So as you can see here, now we have the column names. So the important point to note here is we don't have the price column here because we have just imported this data. We have just imported this data array. We have not imported this target array, which is the price of the houses. Okay, so we need to include or incorporate this price or target array with this data frame, right? So we will do that now. So add the target column to the data frame. So this target is nothing but the house prices, so I'll mention it here, price. Okay, so mention the data frame name, which is house price data frame, z house price data frame, and we need to create a column as price. So price column, which is equal to, mention the data set here. So this is the data set we have. So we need to mention house price data set dot target to load all these data. Okay, so house price data set dot target. So I'll run this now. Now you can again print the first 5 rows. So as we know that this is the function for that. Okay, so yet function. So I'll copy this here and run it. Now you can see that the target column is also add as price. Okay, so but in the previous case we didn't have that target or price column, so we have included that column as well in this data frame. Okay, so now what we will do is we will check the number of data points we have, so number of rows and columns we have. So checking the number of rows and columns in the data frame. So for that you can use the function shape. So house price data frame dot shape. So this gives the shape as 506 into 14, which means we have 506 rows, which are 506 entries and 14 columns. Okay, so including this price, we have 14 column, right? So now what we will do is we need to check whether our data set has missing values. So if we have some missing values, we need to do some more processing steps before we feed the data to our machine learning algorithm. So we cannot feed data set with missing values directly to our model. So it will make our model not to work properly. So we need to check, is there any missing values? So check for missing values. So mention the data frame dot is null. So this is null function checks how many null values or missing values are there, and if we mention this sum as well, this will count the number of missing values. So this will give the number of missing values in each column. So as you can see here, all represents 0. Okay, which means there are no missing values. So if we have missing values, we need to process the data with methods like dropping or imputation. So luckily in this data set we have all the data, so we don't need to do any processing. Okay, so in some other projects I will be telling you how you can handle those missing values. So in this particular scenario we don't have any missing values, so we can continue our step. Okay, now we can get some statistical measures of this data. Statistical measures of the data set. So statistical measures are nothing but the mean, standard deviation, percentage, etc. Okay, so mention the data frame name. So house price data frame dot describe. So this will give the various statistical measures. As you can see here, for each columns we have the count. So count represents the number of data points we have. So totally we have 506 data points, and the mean gives the mean value for this first column, and this is the mean value for second column, standard deviation, minimum value, maximum value, and the percentage. Okay, so percentage means like if 25 percentile, it represents 25 percentage of the value or less than 0.082. Okay, so similarly 50 percentile means 50 percentage of the value or less than 0.256. Okay, so these are some important statistical measures. Okay, so this helps us to understand our data set better. Okay, now we need to do some more data analysis step here. So for that purpose, we need to find the correlation between the data. Okay, so I'll make a text here. Understanding the correlation between various features in the data set. So let me explain what is meant by this correlation in a minute. So basically there are two types of correlation. They are positive correlation and negative correlation. Okay, so correlation basically represents the relationship between two variables. So in this data set, we have various features or various columns, right? So we need to find how these features are correlated with each other. Let's say, for example, we need to check the correlation for first column, which is crime, and Z, and which is the zone value. So positive correlation means these two are variables, right? So in the positive correlation, if one variable increases, the second variable also increases. Let's say if crime and zone are directly correlated, if the crime value increases, zone value also increases. Okay, in negative correlation, if one value decreases, the another variable also decreases. So that is called as negative correlation. So we need to analyze this correlation value between various features in the data set. So totally we have 14 features, right, including the price. So let's understand that. So I'll create a variable called as correlation, so you can get the correlation data from here. So mention the data frame name here. So house price data frame dot corr. So this will give the correlation data. Now we need to, so this correlation data is stored in this correlation variable. So basically what happens is, so the function analyze all these values and find the correlation between all these features. Okay, so for example, the crime value will be taken, and it will be the correlation of crime is checked with all the other columns. So this is carried out for all the other columns as well. So let's now plot that correlation and understand this. Constructing a heat map. So heat map are very useful for finding this correlation between various columns or features. Okay, so constructing a heat map to understand the correlation. So for this purpose, we need to include plt.figure. Okay, so this plt represents matplotlib.pyplot. So as you can see here, we have imported this matplotlib.pyplot as plt and cborn as sns. So these two functions or these two libraries are very useful for making graphs and plots. Okay, so plt.figure. Now we need to mention the size of our plot. So for that we need to mention the parameter as fig size, which is equal to 10 into 10. Okay, so 10 into 10 units. And we need to create a heat map, which is sns dot heat map, and we need to mention several parameters. So we are creating the heat map for this correlation value, right? So we need to mention this here. So I need a correlation for, sorry, a heat map for this correlation value, and there are other parameters as well. So let me complete this parameters value and tell you what this basically does. So c bar is equal to true, and square is equal to true, FMT is equal to 0.1f annotations, which is represented as annote. Annote is equal to true, and annote size NOT AWS is equal to, so we need to mention the size as size is equal to 8, and CMap color, which is the color of the graph, is equal to, let's create the graph with blue color. Okay, so let me run this cell and tell you what this basically does, what all these parameters does. Okay, so this will create the heat map for the correlation value. Okay, so this is the heat map. So as you can see here, we have plotted this heat map for this correlation value. Okay, so we have found the correlation from this function data frame dot corr. Okay, now we have mentioned another parameters as c bar. So this c bar represents the color bar. Color bar is equal to true, so true means we want that color bar in the side. Okay, so this is the color bar as you can see here. So it has various values starting from +1 all the way to negative values to -6, right? Okay, so plus, plus values means positively correlated, and negative value means negatively correlated. So I have already explained you what is meant by positive correlation and negative correlation. So square, so we want all the values to be mentioned in a square. And FMT means how many float values do you want. So I have mentioned dot 1f, so it means like I want one value after the decimal point. So you can see here there is one value after each decimal point. So if I give 0.2f, there will be two values after the decimal points. So that's why we are using this FMT parameters annote. So annote means annotations is equal to 2. So these are annotations. So you can see all these feature names and all the values inside this cell. So these are annotations, and here I have mentioned the annotation size. So if I increase the size here, the size will be increased. The size of this text and the numbers and characters will be increased. And CMap is equal to blue. I have mentioned the color of which I want the heat map to be. Okay, now so the maximum value for the correlation is +1. So +1 means both the values are equal. So if one value increases, the other value also increases. You can see here this diagonal is, this diagonal has the value as 1 because both the values are same. So you can see here we have crime here and crime here also. So the both of them are same values. And as you can see here, this is the zone values and zone values. So both the columns are basically same. Hence this diagonal is dark in color and one. Okay, so dark color represents positive, more positive correlation, and negative color recommends least correlated or negatively correlated. Okay, so this diagonal doesn't, it's not significant for us because both the columns are same. Okay, so what we are basically doing is we are taking all the columns in one side in the y-axis and all the columns in x-axis, and we are checking how these are correlated. So if it is, the particular square is white in color, it represents negatively correlated. That means if one value is increasing, the other value will be decreasing. Okay, say let's say for example we have that this L stat. Okay, so this L stat and this price has a value of minus zero point -0.7, so it is white in color, so it is in light color. So it represents if LSTAT value increases, the price will decrease. Okay, so basically this LSTAT column represents the lower financial status of people living in that particular area. Okay, so if the financial status of people are low, the price of the obviously the price of the houses will be less, right? So that is what is signifies here. And you can see here we have a value of 0.9. So and the color is dark, so it represents this rad column, and we have another column as tax. Okay, so these two columns are positively correlated. So if one value increases, the other value also increases. Okay, so this is how you can find the correlation between various features in a data set through heat map. Okay, so this is very much useful for data science analysis where we need to understand the data more better. Okay, so this is how you can create a heat map. So as we have created the heat map, now we need to split the data into data and labels. So here in this case, the labels are nothing but the price of the data. Okay, so we need to feed this data and label separately to our machine learning algorithm, and through that it can find the pattern between the price and all this data, and this is how it is going to learn from the data. Okay, so now let's separate this data and label. Okay, so I'll create a text as splitting the data and target. So target represents the price or the label in this case. So I'll create two variables as x and y. So in the x, the variable x, let's include all the data, and in y, let's include all the prices. Okay, so let's mention the data frame. So the name of the data frame is house price data frame dot drop. So basically this drop function will drop a particular column. So here I want to drop this price data, this price column. Okay, so I would mention this data frame name here dot drop this price. So this will drop this column. Okay, so x is equal to house price data frame dot drop. Now we need to mention the column name here. So the column name is price, right? So price, and we need to mention the axis as 1. So if you are dropping a column, you need to mention the axis is equal to 1. If you are dropping a particular row, you need to mention that the axis is equal to 0. Okay, now we need to store all the labels in the variable y. So what we will do is we will mention the data frame name, so house price data frame, and we need to mention the column price. So this will store the value of the price column in the variable y. Okay, so I'll run this cell. Now let's try to print x and y. So I'm printing x and y. As you can see here, now in this data frame, the price column is removed and this price column is stored in another variable y. Okay, now we can do some more processing before we feed the data to our machine learning model. So we have done some analysis on this data. So as we have discussed in our workflow, now we need to split the data into training data and test data. Splitting the data into training data and test data. Okay, so we need to create 4 variables: x train, x test, y train, y test. Okay, so I will be giving this x train data to my machine learning model. So basically what I'm doing is, so I have this training data and the corresponding label for this training data will be stored in this y train, and I have this test data. Okay, so this test data will be used to evaluate our model, and the labels for this test data is in this y test array. Okay, now let's use the function train test split. So you can see in the top that we have imported this train test split function from sklearn.model selection, right? So train test split. So here you can mention the x and y. So I hope you know that we have splitted the data into x and y. So x represents all the data, all the 13 columns, and y represents the 14th column, which is the price. So we need to mention that here. So I want to split this x and y into training data and test data. So I cannot do it manually. So for that purpose, we are using the train test split. Okay. So we need to mention the test size. So test size is equal to 0.2. So 0.2 represents I want 20% of the data to be in the test data. So 80% will be the training data and the test data will be 0.2. 0.2 represents 20%. So generally we will be having 10 to 20% of the entire data as test data and 90 or 80% as training data. Here I am taking the test data as 20%. Now we need to mention the random state. Random state is equal to 0.2, sorry, 2. So you can represent any number as 2 or 3. So each value represents one kind of splitting. So what is the significance of this is, so if you use the same value 2 while you are doing this programming, your data will be splitted in the same way my data is splitting. So if you are using the value as 1, your value will be, your data set will be splitted in a different way. So if you want to reproduce the code, if you want to reproduce how this splitting is done in the same way, you need to mention the same random state value. Okay, now I have this x train x test, y train y test. So what happens is, So 80 percentage of the value will be stored as training data, and this 80 percentage labels the value for 80 percentage of this data. So the labels of this data will be stored in Y-train, and the 20 percentage data will be stored in X test, and the corresponding labels will be stored in this Y test. So it can be done with the function train test split. So we need to mention the X and Y. So we have splitted the X and Y here, so as data and price. So I am mentioning X and Y here, and I am mentioning the test size as 20 percentage and the random state. So you can give any number for random state. Now let's run this. Okay, now let's see how many instances are in X train and X test. So X is the original data. So X train, X test. So let's see how many values are there. X dot shape, X train dot shape, X test dot shape. Okay, I'll run this. So as you can see here, in the original dataset, we had 506 values, so which is the X, and in the X train, we have almost 80 percentage of the data, which is 404. And in the X test, we have 20 percentage of the data, which is 102. Okay, so this is how you can split the data. And now we need to train our model. So this is model training. So as I have told you earlier, so we are using the XGBoost regressor model. XGBoost regressor. Okay, so this is the model we will be using. So this is a type of decision tree algorithm. So if I want to be more precise, this is a decision tree based ensemble model. So ensemble means we use more than one models. So it's like incorporating two or more models together. So this is an example of that ensemble model. So and it basically is a type of decision tree model. So I cannot explain detailing about what this model is made of and all the mathematical basis of this model in this video. So as this machine learning course progresses, I will be making separate modules for each of these modules for all the machine learning models. So for example, I'll be making a module for logistic regression and another module. So that module may contain 4 to 5 videos about logistic regression and another module on linear regression, XGBoost regressor, etc. Okay, so in that case I'll explain about all these models, but I cannot explain all of these in this video. Okay, so the idea behind this video is to have the hands-on training and hands-on knowledge about the project we are solving. So it is somewhat difficult to incorporate all those things because we need to discuss a lot of things when it comes to models. So I'll be making separate video for that, but in this videos, in this project videos, I'll be explaining you how you can use these models for your prediction systems. Okay, so in this case we are using XGBoost regressor as I've told you earlier. So now we need to load this model. Loading the model. Okay, so I hope we have already imported the XGB regressor model, so we need to use here. So I'll create a variable as model. So let me name the variable as model. So model is equal to XGB regressor. So we have imported already. So mention the parenthesis. So this will load the XGB regressor model to this variable, which is named as model. Okay, so to this model we need to fit the training data. Here the training data is X train. This fitting is nothing but the training of the model. Okay, so training the model with X train. So you can do that by mentioning the variable. So I have loaded this XGB regressor into this variable called as model. So model dot fit. So this will train the model. So you need to mention the data and the label. So here the data is X-train. So this X-train basically contains the 13 features or 13 columns of the training data, and this Y-train contains the price value of those corresponding values. So we need to mention both X-train and Y-train. So I'll represent it here. So model.fit X-train Y-train. So you can run this. So here the model will be trained, and these are the various parameters in which our models are trained. Okay, so now we can evaluate our model on how well it is performing. So this step is called as evaluation. Okay, so in the previous video for classification problems, we have used the accuracy score as the evaluation metric, but we cannot use the accuracy score for regression problems. So in basically what we will do in accuracy score is we will check or count the number of correctly predicted values by the model and the original values, and we will subtract, find the difference between both of them. But we cannot do that in the case of regression because all these are numerical values. Okay, so we cannot find accuracy score for regression problems. Rather, we find the metrics such as r squared error and mean absolute error. So let me show you how you can find those metrics. So before that, we need to do the prediction. So I'll create a text here named as prediction on training data. So basically our model is trained on this extrained data, and now I'm going to use this model. So this model is now trained, and I'm going to give this extrained array alone, and based on this value our model should predict the value of y train. So once it has predicted it, I will compare the error. I will get the error by comparing the prediction of the model and the original values. Okay, so now let's try to predict the price of the houses with this extrained value. Okay, so we are trying to get the accuracy for prediction on training data. Training data prediction. So for that you can use the function model.predict. So for learning, for fitting the value with the model, we have used the function fit, right? So for predicting we will use the function model.predict. So model.predict mention extreme. Okay, so this will so basically what happens here is the model will predict the price value, okay, the house price value, and store all these prediction to the variable as training data prediction. Okay, now let me run this. So you can just print and see these values. So these are the values predicted by our model, and white train is the original values. So these are the prices of the houses predicted by our model. So these are nothing but in thousands of dollars, like $20,000, $47,000, and like that. Okay, so now we can compare this predicted value with the original value, which are this white train. So while comparing this, we can get the error made by the model by comparing how close is the value predicted by the model and the original values. So for that purpose, we'll be using those evaluation metrics. So first we will use the R squared error. So in classification problem, the common metric used for evaluation is accuracy score, and for regression problem it's R squared error and mean absolute error. Okay, so there are also other errors such as mean squared error and the root mean absolute error and all those things. So in this project we will discuss about only two errors, which are R squared error and mean absolute error. Okay, so I'll create a variable as score one. I'll get the error value and store it in this score one. Okay, so score one. Now you need to mention metrics. So you can see here while importing our libraries, I have imported sklearn.metrics. So from here we can, this particular module metrics contains the function for R squared error, mean absolute square error, etc. Okay, so we will be using those functions. So metrics dot R2 score. So this will give the R squared error for the original values, which is y train and training data prediction. So this training data prediction is the value of prices predicted by our model, and this y train is the original values. So this will basically give the error made by our model. Okay, so what happens here is So this matrix, this R2 square function will find the variance between this data, sorry, this value and this value from this regression. So based on the variance between both of these values, it will give the R squared value. Okay. Now I'll get another value, another error value, which is mean absolute error. So I'll create another variable as score2. Here let's make the function metrics dot mean absolute error. So I want the mean absolute error, and same way we need to mention y-train and training data accuracy. So this will give the mean absolute error. Okay, so this will just find the difference between the original data and the actual prediction. So it basically subtracts all these values from its corresponding original values, and it will give a mean value. Okay, so this will give the mean absolute error. This is R squared error. Okay, so now let's try to print these values. Print R squared error as score 1. So this value should be close to 1. If the value is around 10 or more than 10, that means our model is not performing well. Okay, so it can be 1 or near to 1, or it should be closer to 0. Okay, so if it is 0 means our model is performing perfectly, and it is predicting the values perfectly. So lesser the value, more accurate the model is. So that is the concept. Okay, so now we will print the absolute error value that we have found in the score 2. So mean absolute error, this is shortly called as MAE. Mean absolute error is given by score 2. Let's run this and print the error value. As you can see here, the error R squared error value is 0.973 and mean absolute error value is 1.14. So it's not very much larger, around it's not around 5 or 10. So if the value is around 5 or 10, that means our model is not making good prediction. So here the value is pretty small, which means our model is performing really good. Okay, so we can get more accuracy and we get very less error values also if we use more data and other models. So we use XGBoost regression model because we have a very less, very less sized data set. So we only have 506 data points, right? Typically in a machine learning projects, we will be having thousands and even lakhs of data. So more the data, more accurate or more, well our model performs. So, but this is actually a pretty good accuracy score. Okay, so this values is not very much higher. So our model is working well. So you need to note another main thing here. We have made the prediction on the training data, but there is another one more thing that is important. So we need to find the error value for the testing data as well, because the model already seen the value of training data, but it didn't see the value for test data. Okay, so it is just like a student preparing for max exam. Let's say that person is preparing several questions, several example questions given in a book. Okay, so those questions become the training data. So in the exam you will be asked to answer several problems that are not in the book. So this will tell how well the student is performing or how well the person is knowledgeable about that particular topic. So those questions that are asked in the exam are called as testing data. So more than the accuracy or error value of this training data prediction is more is important when it comes to test data. Okay, so the test data values are more important than this training data. So I'll also create the error value for testing data as well. Prediction on test data, because for evaluation test data value is more important. Prediction on test data. So we can just copy these things. So we just need to change here as test data accuracy. Okay, so test data prediction. So we have already splitted the test data as X test, right? So run this cell. accuracy on the prediction for test data. Okay, so let's not print it. Now we need to find the error value for test data, right? So I'll copy this and change the x test values. So score1 matrix dot r square. So here we need to mention y test because we are checking for the test data prediction. Here also y test and test data prediction. So now we can run this and see. So it is almost similar to the value for training data. Okay, so our model is performing fine. So for training data, the R squared value is 0.973, and in this case, it's 0.91. Okay, so this is the prediction on test data. Okay, so this means our model is performing pretty good. Okay, now what we will do is we will just try to plot and see this uh, error values. So I'll create another cell here. So I'm going to visualize the actual prices and the predicted prices. Okay, so what I'm basically trying to do here is I'm going to get the original value for prices, which is y train, and the training data prediction. I'm going to plot that in a graph to see how close these values are. Okay, so how close our model is predicted. So for that we need to make a scatter plot. So plt.scatter. So we have the scatter plot function in matplotlib. So plt.scatter. We need to mention the two values, which is y train and training data accuracy, because I'm comparing those two values, right? The original prices of houses and the price predicted by the model. Okay, so plt.scatter, plt.xlabel. So this is just naming the x-axis and y-axis. So plt.xlabel, let's label the x-axis as actual prices, actual price, and let's label the y-axis as label. This is the predicted price. So we will try to plot these two values and see the closeness between them. plt.title, let's name this graph as actual price versus predicted price. plt.show. So this will print the graph. Okay, so we are plotting the scatter plot for y train, the original value and the predicted value, and I'm naming the x-axis as actual prices and y-axis as predicted prices, and we are naming the graph as actual price versus predicted price. So we will get a scatter plot. So as you can see here, this x-axis contains the actual price, which is y train, and the y-axis contains the values predicted by the model, which is named as predicted price. So as you can see here, all these data points are very close to each other, which means the value predicted by our model, which is in y-axis, is very much similar to the actual prices of the houses given in the data set. So this is how you can visualize the closeness between your model's prediction and the original data points. So this is our agenda for this video. So we wanted to make a predictive system that works fine if we give a data, and if we want to predict that house data, sorry, that price data. Okay, so let's do a very quick recap to understand what we have done step by step. Okay, so first of all, we have imported the libraries. So we have imported several libraries like pandas, matplotlib. So matplotlib is basically for making plots and graphs, and then we have got this sklearn.datasets library for loading the dataset file. And then we have this imported this train test split function to split our data into training and test data. So and all those importing the dependency step is done in the first cell. Then we have loaded the Boston house price data and stored it in the variable in the array called as house price data set. Okay, so we have printed and checked this data, and we have created a data frame and stored it in the variables as house price data frame. So once we have did that, we have included this target, which is price value, to this data frame, and we have seen the values for the first 5 rows. And then we have found the shape of the data frame, which is 506 rows and 14 columns. Then we have checked whether the data frame has any missing values, and then we have checked some statistical measures, the mean value, standard deviation, etc. for this data frame. Then we have discussed about how we can find the correlation between various features through heat maps. Okay, so then we have splitted the data set into the data and label, right? So after that, we have splitted the data into training and test data with the help of train test split function. So this is one of the main steps in this use case where we need to split the data set. So we have took 20% of the data as test data, and next we have trained our XGBoost regression model by using this XGB regressor function. So once we train the model with this fit function, we have evaluated the model for both training data as well as for testing data. So this is the prediction on test data, and we have got very good error values. The error values is quite small, which is very good, and we have visualized how close the actual values and the predictive values is. Okay, so this is how you can make a prediction system for house price with this Boston house price data set. Okay, so I hope you have understood all the things covered in this video. So if you have any doubt, you can mention it in the comments below. So subscribe for more videos. I'll be uploading project videos every Friday, and stay connected. Thank you.